Hey there, fine folks of the Blenderverse. I'm Chris, and in this tutorial for the Trip Tilt YouTube channel, I show you how to create an interesting and beautiful motion graphics animation with Blender geometry nodes based on the artwork you see on your screen right now. This feast for the eyes is the previous upload on this very channel, featuring a soundtrack that totally fits the visuals. To not have an endless tutorial, I compressed everything I learned during the creation process into this smaller bite of a tutorial. The basic principles still apply, how to think with geometry nodes and how to use it as well. But the result of the tutorial is more like this. The final fine-tuning steps of setting up the light, animating the camera and compositing is missing. Otherwise, the tutorial would be 20 minutes longer, and I want to teach you about the procedural geometry generation and the procedural shaders in this one. But enough of the intro, you know what you're getting into. Let's open Blender. Under Edit, Preferences Add-ons, we search and activate Node Wrangler. That makes working with nodes a lot easier. And then, whoop, switch to the Geometry Nodes workspace and change the spreadsheet for the graph editor, and we can get started. We make those pill elements with a single cylinder primitive and dial down the depth value, that is the height. Then we pipe it through a subdivision surface node that does the same as the modifier with the same name, which is that we get more geometry and thus everything gets rounded. The side segments of the cylinder are the loop cuts along the side of the cylinder, while the fill segments are more like insets on the top and bottom side of the cylinder. I like the level of roundness with a value of 5 for the fill segments. Set those support loops to a value you like. It is also possible to only have one fill segment in geometry nodes, select it and scale it bigger, closer towards the edge. But this is too complicated when I can do it like this. But this way we generate more geometry and Blender has to calculate more data with more vertices. Then we use the Set Shade Smooth node to even out the shading of the rounded mesh. And with the Transform Geometry node we set a rotation of 90 degrees around the y-axis. And with this we created the basic building block from which we will build the whole setup. To get the cylinder blobs all lined up like pearls on a necklace, we need the string inside the necklace. The simplest solution is often the easiest. A simple mesh line is good enough to put the cylinder pills in line. With an offset along the x-axis and no offset along the z-axis, we get the line going in the right direction. With the Mesh to Points node, we transform every vertex we created with the mesh line into a point on which we can put other objects as instances. And exactly this is what we do with the Instance on Points node. We use the rounded cylinder as instance, and there we have our row of blobs. And now we make it really procedural by using mathematics. With an integer node, we set only whole numbers as the number of the mesh line sections, and this logically controls the number of cylinder instances. Now let's take care of the form of the instances. We'll recreate this curve I sketched in here, and this is easier when you put the middle of the curve on the world origin. As you can more or less see, the whole curve has a length of 2 Blender units. 1 unit on each side of the origin along the x-axis. So the first thing to do is set the mesh line to the correct length. So we use a math node to divide the length of 2 that we just defined by the number of instances and feed that result into the x input of a combine xyz node. Once the math node is indeed set to divide, this works. And when we set the height of the cylinder to the same value as the distance of the cylinder, those are a perfect fit and we can instance as many pills on the 2 meters of mesh line as we want. Actually, I think this is too tight. So I put another math node in there, which I use to subtract a small amount from the height. Well then, with a transformed geometry node and an x position or x translation value of -1, we have everything in place. And this value field is where we also animate the movement that I currently display manually. But you surely notice, when we move to, say, -2, there are a few blobs missing already. And for this reason, we duplicate the number of blobs with a math node by multiplying with 2. Preferably only the value that goes into the value for the number of meshline segments. Then it still adds up. To get the whole thing moving, I put a keyframe for the position at -1 on the first frame, set the length of the animation to 96 frames or 4 seconds, jump to the end, and to get a perfect loop, on the one hand I skip ahead one more frame and set a keyframe for the position -3, and on the other hand I change the interpolation between the keyframes to linear. Good. We moved everything by the 2 meters that the curve is supposed to be, and there are still blobs in the range from -1 to 1. That works already. To bring those instances into shape, we don't do a workout, but we use math. To apply those mathematical instructions, the scale instances node is useful. We use the combine XYZ node to control the scaling of the different axes individually. With the vector from the position node, we get some coordinates already, but they are not useful like that. As we see, each instance has the same x coordinates that go through each instance. The realize instances node has a similar effect to applying a modifier. In this case, the position node sees all instances on the necklace no longer as separate elements, but as one single object, and draws the coordinates through the whole object we created. We split this vector with the separate XYZ node and use especially the number line along the x-axis to scale the necklace along the other 2 axes. With the map range node, we map all values from 0 to 1 as 1 to 0, and thus reverse the mapping. Plugging a math node set to absolute before that turns all negative values into positive values. This works really well when the object goes through the origin. Then we can just mirror the values. Setting the interpolation of the map range node to smoother step makes Blender automatically turn the linear number line into a nice curve. That's the same as setting the color ramp to easing or changing the keyframe interpolation to Bezier. Now that looks okay already. Now let's put a lot of the pill necklaces next to each other. To do that, we need points again, on which we can place those builds. In geometry nodes, we don't have a plane available as primitive, but we have something even better, the grid. We can add as many loop cuts to that plane as we want, and we need quite a lot. When I use a grid, I like to build a setup like this, so I can set the same value for the x and the y, and keep the grid square in shape. Also, I used some math to put the complete size into relation to the number of vertices, but I'll remove that again soon. First, we use an instance on points node and use the necklace as instance, and also rotate the instances by 45 degrees around the z-axis. And we are already starting to fill the plane. There surely is some algorithm to ideally fill the plane, but this also depends on the thickness of the blobs at the edge of the curve. So I just multiplied it until it looked good to me. Quite a reasonable thing to do once in a while, when the other option is spending 30 minutes going crazy developing the formula to make it fit, and in the end it doesn't work. When you multiply the value used to scale along the z-axis, you can control the height of the whole thing. Cleaning up is also useful sometimes. Use Ctrl-J to join all nodes into a frame, and since then the frame is already selected, hit F2 to give it a name. So, let's bring in some color to make it shine. A mesh object in Blender that has a geometry nodes modifier, and with this consists of generated geometry, loses all the materials you set in the Materials tab. You set the material in geometry nodes. This makes sense if you want to set different materials for more than one generated mesh. But don't delete the material from the material slot, or Blender might see it as unused material and delete it when you change it in geonodes and close the project. Well done. Very surprisingly, we used the set material node to set the material of the object. I used the default material called material that Blender always creates. Open the shader editor and check if it works by changing the color. Then I set a uniform scaling, and to make it easier to work on the shader, I changed the mapping so that I can see the whole construct. Pressing Ctrl-T with activated node wrangler and active PBR shader brings in the texture mapping, and we only need the texture coordinate node from that. To test the loop, I use the color of a Voronoi texture that is attached to the generated coordinates. And as you can see, the colored areas jump around when the animation loops. We need to work on the individual coordinates of the texture. For that, the separate XYZ and combine XYZ node are very helpful. When you connect them all through, there is no change, of course. That should be quite logical. Alt and right mouse button dragging is the lazy connect function of Node Wrangler, and that works pretty well in this case. Then we throw a math node set to multiply on the x coordinates. This compresses the number line. A multiplication stuffs more numbers into the same distance. Times 2 is enough. Another math node set to fraction gives us just the fraction, the value behind the decimal point. So we receive values from 0 to 1 again. Well, from 0 to 0.99999, and the 1 is 0 again. Otherwise, there would be something in front of the decimal point. Then I use my special noise texture. If you ask me, everyone should have a special noise texture in their asset browser. But if you followed along up to here, it should be no problem for you to recreate that little node group or even improve it. And I use the output of this node for the roughness of the material, and with a color ramp I dial it in so that it looks really crisp and tasty. You should see all those sweet details, even with the YouTube video compression. For the color of the necklace, we use the output of the fraction node, as it only changes along the x-axis, and that's what we need. Using a color ramp with the same color on both ends, set to HSV or HSL, and far gives us all the colors of the rainbow. The math node set to snap gives us fixed values in defined steps. And since Blender can calculate, I set it to 1 divided by 12, a 12th. for the 12 elements that should be visible in the end. And after a short test, I see it works. But it is not really procedural and dynamic with the hard-coded value there. So we plug through the dynamic value coming from geonodes. We use the store named attribute node in geonodes for that and plug it in behind the mesh line to have some geometry plugged in. Otherwise, it does not work. In this case, we could plug the store named attribute node anywhere into the geometry flow. But here we are closest to the integer node that gives us the value with the number of the blobs. And we plug exactly this value into the value input. Set the data type to integer and name the variable. And now back to the shader editor. We use the factor of the attribute node after entering the attribute name to divide the one visible element by this dynamic value. Looking great already. Now I set back the mapping to hide the doubled elements and show the complete grid of colorful elements. Nice. Let me show you how good this works. You can just use a differently colored color ramp and the setup generates the gradient of flat colored elements. And the slider for the number of the elements also works and generates interesting variants by the push of a button or the drag of a slider. It is colorful, it is moving, and it is procedural and dynamically controllable with numbers, math and sliders. You can give yourself a pat on the back already when you made it up to here. And since there is still a bit time left in this tutorial, I show you how I made those distancer blobs between the colorful pills. For this, we go to geonodes and copy the transform geometry node, the scale instances node, the realize instances node, and the set material node. Since we will have two materials now, a better time to define the material of the first necklace is of course before we use it as an instance. And we set the material for the second necklace there as well. Whoa! Short insertion from future me. Here I show you how to join both pill stacks and use them as instances. It turns out that this makes the whole object a bit bigger and this screws up all the math we used during the last few minutes, and the fix is to first instance each pill necklace on a grid and then join those geometries. This setup is not in the rest of the recording. We create a second material and turn it black. You can use the super special noise for the roughness again, but I want to get this tutorial done one day, so I should rather show you that we also need the map range to multiply the combine XYZ node here as well. Turn the scaling a bit smaller than 1 and set the X value of the combine XYZ node smaller as well to make it fit into the gap. Then we move the second necklace by half the height of the cylinders of the first necklace and this on the X-axis, and thus this fits pretty well. The rest is fine-tuning and experimenting. And this can easily turn into a lot of more work. Have fun with that. Oh, by the way, You can watch this whole animation in full with a spaced out soundtrack on this very channel. It's linked below, and it's probably worth it when you like art and colors, music and MoGraph. And I'll sure hate it when this tutorial gets way more views than the actual artwork. But that's digital art in the 21st century for you. There are quite some inspiring Blender animations with enjoyable soundtrack together with interesting tutorials gathered on this channel. Just look around. Just for your interest, for that really polished version of the artwork, I used like 4 times the length of a single curved band, thus the longer stretched gradient, and then more lights and compositing and a touch of magic. I hope I get to explain the lighting and the compositing for MoGraph animations in another tutorial soon. Stay tuned. But for now, I'll put the source file for the finished animation on my Patreon, on a paid tier though. You can support me there, thanks a lot already. Link is in the video description. Also, make sure to follow this channel. Like the video and press some more buttons. The service on the internet you watch this on offers you to click around on. Maybe watch some of the really recommended videos on your screen right now. And then this is the end. TT out.